Yeah, good day, good day, good day. Now, welcome back to Apostle 1 tutorial. Yes, now this is Apostle 1 tutorial. If today is the first time you are visiting my channel, make sure you subscribe to the channel and then you share to friends. Yeah, make sure you turn the notification bell on so that anytime I upload a video, you'll be the first person to get it. Yes. Now, this time around, I am going to talk about indices. Yes, I'm going to talk about indices. Now, if you want to contact me for anything, you can call me on this number 0557886424. If you want any special online classes, you can contact me on this number. My name is Apostle. Now let's talk about this one. This one is indices. I'm going to take you through indices. Now listen. Now, this indices is one of the important topic in mathematics, yes. And then it is not only indices, it is contained. You can find indices in all the topics from beginning to the end, yes. Now, indices was first introduced by a certain mathematician called Michael Stefel. Yes, he introduced indices, and then he was using base 2 to talk about the indices, and then before then, and then other people also introduce other ways of solving indices using a different basis. Now, this indices is a plural form of the word index. Now, this one is the plural form of the word index. Now, this word index also means power or exponent. Now, please follow me carefully. It means power or exponent. Now, the word exponent came from a Greek word or a Latin word, expo. Now, this expo means out of. And then ponera. Now, this ponera means that places. This means places or different places. Now, so when you combine the word exponent, we are talking about out of places, which means different places. Out of place here, which means different places. Now, let me talk about some application of this particular instance. This one is really applied in real life situation. Yes. Now, some of you think that we are not learning mathematics for anything, but all the topics have a particular application that it plays in real life situation. Now, this indices is used for statistical analysis. Here, if you want to do any statistical analysis, you can use this particular indices to it. Now, this one is used to determine the population growth. Yes, when talking about population growth, you can use indices to determine the population growth every year. Now, you can use the same indices to determine in the financial, you can use it in the engineering field, you can use in the financial field, yes, when we are talking about anything related to finances, or this one, we'll talk about the loan thing. Yes, we use this particular indices to talk about, use it to predict particularly future investments we can enter. Yes, we can also use this one to determine the loan. Yes, the loan growth. You see, those that they deal with student loan, compound interest, they use indices to do that. Yes, and then we have a lot of formulas that you can use to determine those things. So the compound interest is a result of what? It's a result of exponential expression, exponential equation. Yes, that leads to this compound interest. Yes, so you can use to determine the inflation rate and then other things. Yeah, so this particular indices is really applicable in real life situation. Now, I don't want to talk much, that is why I just want to hit on specific things. And this one is really applicable. Now, so when we talk about indices, what does it mean? Now, so we said exponent or power. So when we come to mathematics, we deal with numbers, yes. So we can have a number like 2 exponent 2. A number like this. This number is in the form of index. This number is in the form of index. 2 exponent 2. Now when you have 2 exponent 2, or a variable exponent something. Yes, we can talk about anything. Yeah. Now, when you have something like this number here, the A is called the base. And then the N here, the A is called the base, and then this N is called what we call the index or power or exponent. Now it means that this 2 is the base and this one is the exponent. So we call this one 2 exponent 2. This one is A exponent N. Now when we say 2 exponent, what does it mean? Now this exponent here talks about number of times the base multiply itself. So this one is just a repeated multiplication of itself. It's a repeated multiplication. So when we talk about indices, we are talking about repeated multiplication. Yes. So if I have something like this, A exponent N, it means that this particular A is multiplying itself. It's multiplying itself n times. So the n represents the number of times. It is multiplying itself up to what? Up to n times. N times. Yes. Now, so what does it mean? If I have a 2 exponent 2, it means the 2 is multiplying itself 2 times. The 2 is multiplying itself 2 times. If I have 5 exponent away, it means the base 5 is multiplying itself 3 times. So the 3 here, the exponent talks about the number of times the base is multiplying itself. The exponent talks about the number of times the base is multiplying itself. Now, so this one means that the base 5 is multiplying itself 3 times. 3 times. 3 times. Now, so how are you gonna do it? Now, this one means that now let me multiply this one. 5 times 5 is 25. Now 25 times 5 will give us 125. Now this one is the index form. This one is called the index form or the exponential form. Yes. Now this one is the expanded form. Expanded form. And then this 25 is the value. Now, so what is going to happen is that it's different. Sometimes they will give you the value and you have to express this in the form of the index form. Sometimes they will give you the index form and then due to the question you're supposed to express in the form of what value. Yeah, so we are going to do all these things. Yes, so don't forget this one is the index, this one is the expanded form, this one is the value. So when they give you value and then they ask you to expand this one, the value into index form or index notation, it is the same thing. This one is index form. Now, so let's look at this. It means we can talk about plenty things like 4 exponent 3, which means 4 multiplying itself 3 times 4 times 4 times 4. Now 4 is 16. 16 times 4 will give us what? It will give us 64 in that order. The index form, the expanded form, and then the value. So anytime I'm solving questions and I get to know 64, I know that 64 can be expressed as 4 exponent 3. Now, so let's look at something small. Now they can also ask you to express this one. Express this in index form. Now this one means that I have to look for numbers that can multiply to give you what? 32. Numbers that can multiply to give you 32. Which number can multiply to give you 32? Unless I use 2. 2 times 2 times 2 times 2. When 2 multiply itself 5 times. When 2 multiply itself 5 times, I'm going to get 2 exponent 5. And that is what? The 32. So this one is the value, this one is the expanded form, and this one is the index form, 2 exponent 5. So you can have to be able to know within those things. Now, but one thing is that we have something called rules. Now, when we are dealing with indices, we have to deal with rules because it works with rules. So we follow the rules and then we use it to do any question that we are talking about. Now, so with this one, we have a lot of rules I'm going to talk about. So I'm going to talk about the rules and then prove them narratively. So rules of indices. Rules of indices. Now the first one, now I'll be writing and then be cleaning. So the board is too small, I'll be writing and cleaning. So pay attention very well. Now the first one, I'm going to talk about the multiplication rule. The multiplication rule. Multiplication. Now if I have a exponent m multiplying a exponent n, now the rule says that when we have two numbers multiplying and then the bases are the same, so this one is in the form of an index, this one is in the form of an index, this one has a base of a, this one has a base of a, this one has an exponent of m, this one has an exponent of n. Now anytime the bases are the same, take note, if the bases are the same and they are multiplying, what you have to do is that you take one of the bases, then you add the exponent. So in other words, the multiplication here means addition. So you add the exponent. The multiplication means addition. So this one has an exponent of m, then plus this one has an exponent of what? N. This one has an exponent of n. Now let's look at something. Example. If you have 2 exponent 3 multiplying 2 exponent 4, what are we saying? What we are saying is that take one of the base, and since this one is multiplication, you add the exponent. The exponent of this one means 3 is 3. The multiplication means addition. Addition of exponent. So plus this one has exponent of 4. So this one gives us 2 exponent 7. Now this one is so low that this one, what you're talking about, is 2. Now let me prove this one. Let me prove. Now let me prove this one. If I have 2 exponent 3 times 2 exponent 4, if these ones are variables and I can't expand them, so I'm going to use numbers to prove them. So I have 2 exponent 3 times 2 exponent 4. Don't forget that for the expanded form of the 2 exponent 3, it means that the 2 is multiplying itself 3 times. So I'm going to have 2 times 2 times 2. The 2 is multiplying itself 3 times. Now, and then this one means the 4, the 2 is multiplying itself 4 times. So I'm going to have 2 times 2 times 2 times 2. You understand? 2 times 2 times 2 times 2. Now, how many 2's are you going to have? You have 2 times 2 times 2. That is for this one. Then times 2 times 2 times 2 times 2. Now, this one, look at the 2's we have here. How many times the 2 is multiplying itself? 1, 2, 3, 4, 5, 6, 7. Now, the 2 is multiplying itself 7 times. So we are going to get 2 exponent 7. Don't forget that I explained that anytime we have 2 exponent 7, it means the 2 is multiplying itself 7 times. You get it? Yes, 2 is multiplying 7 times. Now, so this one shows that what we have done here is true. So without going through this long process, that is the expanded form, what you can simply do is that you just have to add the exponent. 3 plus 4, which will give us what? 7, rather than going through this particular process to get the answer. And this is what we call the multiplication rule. I have proved this one for you. Multiplication rule. Now, let me talk about another example using the same multiplication rule. Sometimes the questions will be in the form of variables. So example, if I have something like this, example, if I have y exponent 5 multiplying y exponent 3. Now don't forget that the bases are the same, y and then y. So you take one of the base, and since they are multiplying, the law says what? Add the exponent. So I'm going to add the exponent 5 plus what? 3. Now this one means that y is multiplying itself 5 times there. y is multiplying itself 3 times. When you add everything, you're going to get y multiplying itself how many times? 8 times. And this is what we are going to talk about. Yes. So it can be in terms of numbers, it can be in terms of variables. Now let me talk about another one. Another example, if I have 2x exponent 2, now multiplying 4x exponent 3, how are we going to solve this? Now if we are solving these questions, we have 2x exponent 2, 4x exponent what? Exponent 3. How are you going to solve it? Now this one is the number, this one is number, this one is variable, this one is what? Variable. Now the x and an x, they have the same base. What I'm going to do is that I'm going to multiply the coefficients, the numbers, then I'll multiply the variables. Don't forget, they are all multiplication. So when I multiply the next, I have 2 times 4. The 2 times 4 will give me 8. 2 times 4 will give me 8. Then I will multiply the variables. Now we are having x exponent 3, x exponent 2 multiplying x exponent 3. Now since they are multiplying, the rule says that we have to add the exponents. So this one means x exponent 2 plus the 3. We are adding the exponent. This one is exponent of 2, this one is exponent of 3. So we're going to add the exponent, and this one gives us 8x exponent 5, because 2 plus 3 will give us 5. So you're going to see a whole lot of questions that comprises of something like this, and it's very simple to solve. Now let me talk about another rule, that is the division rule. We have the division rule. Now let me talk about division rule. Now rule number 2. Now rule number 2, division rule. If I have a exponent m divided by a exponent n. Now if you have a exponent m divided by a exponent n, you see this one is also the same as a exponent m. This division can be written as this, a exponent n. Now the rule says that when they are dividing, either like this or like this, when they are dividing, you subtract the exponent. You subtract the exponent. So this one means that we are going to take one of the a, because they have the same base a, then we subtract the exponent. So to be m minus the n. Don't forget, the division means the subtraction of exponents. So we have the m, then minus n. So the division can be in this form or can be in this form. Now let me prove this one using numbers. Now example, if I have 2 exponent 7 divided by 2 exponent 5. Now how are you going to solve this one? How are you going to solve this one? Now 2 exponent 7 divided by 2 exponent 5, it means that I can also write this on the form of 2 exponent 7 divided by 2 exponent 5, right? And what's the meaning of 2 exponent 7? 2 exponent 7 means the 2 is multiplying itself 7 times. So I'm going to have 2 times 2 times 2 times 2 times 2 times 2, 6 times 2. The 2 is multiplying itself 7 times. Now divided by the down one, 2 multiplying itself 5 times. So I will have 2 times 2 times 2 times 2 and then times 2. Now what is going to happen here? This one will cancel this, 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 this one will cancel this one. So the whole answer now is 2 times 2. And what is 2 times 2? 2 times 2 means that the 2 is multiplied itself 2 times, which will give us what? 2 exponent 2. Or if we apply the first property, this one multiplication property, this one having the exponent of 1, this one having the exponent of 1, so you add the exponent, the first property. You add the exponent 1 plus 1, which will give us what? It will give us 2. Yes. Now what we are saying is that you don't have to go through this process when you are solving plenty questions. What you have to do is that you just have to subtract the exponent. So when I'm solving a question like this, 2 exponent 7 divided by 2 exponent 5, I will just take one of the base, then I will subtract the exponent, because the division here is subtraction, just like this. So we're going to have 7 minus 5, which will give us 2 exponent 2, which is the same as what we have here. So we don't have to worry ourselves doing a whole lot of things, writing it in the form of expanded before we go over. You understand? Before we go on solving the question. So we just subtract the exponent and then we are done. Now, so let's look at an example. Let's look at examples here. Let's look at examples here. Now, so example, if I have two exponents, 4 divided by 2. Now, 2 exponent 4 divided by 2 will give us what? It will give us 2. You take one of the base, this one has a base of 4. The division means minus, so minus. This one has an exponent of 1, but we don't write. It's only have to have any number having no exponent. It means the number having an exponent of 1, because number is multiplying the follow 1 time. Yes. So this one gives us 2 exponent 3. Yes, the question can be in so many ways. Now you can also get something like, let me combine division and the multiplication to solve one question. In multiplication, they give the 2 roots to solve a question. Now 7 exponent 4 times 7 exponent 2, now divided by 7 exponent 3. Now what will be the answer? Let's see. Now, so I'm going to deal with the top one, 7 times 7 exponent 2. So we have 7. The multiplication means that we have to add the exponent. So I have 4 plus 2. Now divided by 7 exponent what? Exponent 3. Now what is 4 plus 2? 4 plus 2 will give us 6. Divided by 7 exponent what? 3. Now what's the meaning of this one? What is happening here is division. What's the meaning of division? Division means subtraction of exponent. Don't forget. Now so I'll take one of the base, then I'll subtract the exponent. So you have 6 minus 3, which will give us 7 out of what? 7 exponent 3. Now this one is the index form. If you want to write this one in the form of a value 7 exponent 3, you can punch in the calculator to get the answer. Now so with this one, the combination of what? The division and then multiplication. Division and then multiplication. Now I'm going to talk about one question. I'm going to talk about another question that make use of the same division and multiplication. Oh, okay, let me talk about the next rule. But let me solve one question using a variable. So we can also get y exponent 5 divided by y exponent 2, which means you take one of the base, then you subtract the exponent. This one is 5. The division means minus. So minus what? 2. This one gives us y exponent 3. Just as simple as that. Now let me go to the next rule. I'm still talking about the rules. And then as time goes on, I'll refer you back to the rules, so pay attention carefully. Now let me talk about the third rule. Third rule, I'm talking about bracket with an index. Bracket with an index. If you have a bracket A exponent m. Now when you have A exponent m, this A can have another exponent. Okay, so let me say this A is having an exponent of n. Now if you have a question like this, how do we solve? The rule says that, you see, then we have A exponent n into bracket another exponent, this one double exponent. So it means that it's very simple. Use the m to multiply the n. So this one means we have A exponent n times m, which will give us A exponent mn, because this bracket means multiplication. So the rule says that when you have something like this, just multiply the exponent. Now these 3 rules are the basic rules. I'm going to talk about another rules. Yes. Now so for example, if I have 2 exponent 3 having another exponent 2. Now the rule says that use the 3 to multiply the 2, multiply the exponent. So this one gives us 2, 3 times 2, which will give us 2, because the bracket here means multiplication. This one is exponent to another exponent. Yes. So this one gives us 2 times 3 will give us 6. Now if I want to prove this one, I can still prove it. If I have 2 exponent 3, we are proving why this one is 2. If you have 2 exponent 3, now what is the meaning of this? Now this means that the 2 exponent 3 is having an exponent of 2. What does it mean? Just like if I have a exponent 2, it means the a is multiplying itself 2 times. So if I have 2 exponent 3, it means 2 exponent 3 is multiplying itself 2 times. So I'm going to have 2 exponent 3 multiplying another 2 exponent what? 3. So 2 exponent 3 multiplying itself 2 times. Now, if 2 exponent 3, if you have 2 exponent 3, the expanded form will be half. The expanded form is the same as 2 times 2 times 2, because it means the 2 is multiplying itself 3 times. Now, and then what about this one? The expanded form is 2 times 2 times 2. Now, so what we're going to have here, we have 2 times 2 times 2 times 2 times 2 times 2. So what I'm going to have, the 2 is multiplying itself 6 times. Yes, the 2 is multiplying itself 6 times, because you have 1, 2, 3, 4, 5, 6. If you want to use the multiplication rule, the first rule, it means this one is 1, this one is 1, 1, 1, 1. And then multiplication means what? Addition. So you add all the exponents. Follow me carefully. I am explaining all the properties. So follow me very well. Now, I want to still talk about this one. Now, we are still on the exponent. We are still talking about the exponent. Now, so this one means that if I have 4 exponent 3, all exponent another 4, what does it mean? It means we have 4 exponent 3 multiplying 4. So we have 4 exponent 3 times 4 will give us what? It will give us 12. Now these are some of the things we can talk about. So anytime you see something like this, exponent having another exponent, you just have to multiply the exponent. It's very simple. You've seen the proof, right? Now let's move on to another property which is also similar to this one. Now, let me check this one as property 4. Property 4. Now I'm going to talk about the fact that we have a 2 product or 3. You can get 2 or 3 products here. 2 or 3 products. It means that I have let's say a product of 2 numbers here. So a product of 2 numbers, like if I have A, B, all of them have an exponent of m. A can have an exponent, B can have an exponent. But at this point, A is having an exponent of 1, B is having an exponent of 1. We can go to a situation where A can have an exponent of 2, B can have a different exponent. Now, if we have A, B exponent m, what does it mean? Now, this is the fourth rule. Now, it is so simple, just like the A affects this one, the M multiplies the A. It's the same thing as this one. So this one, the M affects the exponent of the A, the M multiply the exponent of the B. So I'm going to have the M multiplying the exponent of the A, because this one has an exponent of 1. So let's say I have 1 times M, and then AB means A times B. Let me use the dot to multiply. The dot means multiplication. Now, then I'll have 1 times what? M. So what are you going to get? We are going to get A, 1 times M is M, B, 1 times M is the same as M. So anytime we have A, B exponent M, use the M exponent to multiply the exponent of the A, use the M to multiply the exponent of the B. Now, another one is if I have A, this one is having the exponent of X, B, this one is having the exponent of Y, all M. What are we saying? Is the same thing. We have AX, the M will multiply the exponent of the A, which is M. Now, multiplying the M will multiply the exponent of the B, which is Y. So we have Y times M. So we are going to get A exponent XM and then B exponent YM or MY. You can also write this one as MS and then this one as MY. Yes, because you can arrange in a particular. You need to keep this particular concept in your head. Now let me prove this one. Let me prove this particular property. Let me prove this one. Now proof. If I have 2 exponent array, okay, let me say 2 x exponent 2. Now all, let me make it x exponent 3. Now all exponent 2. What is the meaning of this? Now we said that the exponent will affect what is inside the bracket here. So the exponent will affect the 2, the exponent will affect the exponent of the x. You get it? But at this point, let me show the normal solving, and after I will prove it. Now, so we have 2 is having 1 exponent of 1, and then all of them are having exponent of 2. So to multiply the 2, and then when we consider the x2, x is having exponent of 3. Now all have an exponent of 2, so the 2 will multiply the 3. And what are you going to get? We are going to get 2 times 1 is 2, multiplying x, 3 times 2 is 6. Now what is 2 exponent 2? 2 exponent 2 is 4. It means 2 times 2, exponent form, the value is 4. Now this one is x exponent what? Exponent 6. Now let me prove this. So it's just like multiplying, but let me prove this one. This is how I will use 4. This is how I will use 4. Now, so it means that I'm going to get 2x exponent 3 all exponent 2. Now this one means that the 2x exponent 3 is multiplying itself 2 times. So I will have 2 exponent x exponent 3 multiplying 2x exponent 3. Now how do we find this one? Because this one is square, so multiplying it 2 times. Now 2 times 2 will give us 4. And don't forget that the x exponent 3, x exponent 3, they are multiplying. So since they are multiplying, we need to add the exponent. So we have x exponent 3 plus 3. Because this one is 3, this one is 3. So the whole will give us 4x exponent what? 6. So it is just very simple. But because we want to make use of time, what we're going to do is that we multiply this one by this, exponent of the 2, which will give us 4. Then we use the 2 to multiply the exponent of the x, which will give us 6. So within one step, you can just solve it to get the answer. And that is what I'll be using when we are solving proper questions. Yes. Now, so this is actually the proof. Now, let's move on to another question. Now, let me explain this one again. Note this. Note, it was AB exponent m. This one, if you have a plus b exponent m, it is never equal to a exponent m plus b exponent m. Don't forget that this one is multiplication. This one is addition. Multiplication and addition, they are different things. What we are talking about is multiplication, not addition. So a plus b exponent m, don't come and tell me that you are going to use the m to multiply the exponent of the a, the m to multiply the exponent of the b. Now this one is different. So if you have a plus b all exponent 2, it is not the same as a exponent 2 plus b exponent 2. This one is never the same. So don't forget. Yes, don't forget. Now I'm still talking about property. Now let me talk about property 5. Now property 5, I'm going to deal with the same concept, but they are not multiplying. The index are not multiplying, they are dividing rather. So if I have a divided by b having an exponent of m, the a can have a different exponent, the b can have a different exponent. Now at this point they are dividing. At this particular point they are dividing. Now after this, I will explain another concept you're supposed to have a look at it. I will explain another concept, so pay attention carefully. Now the property is so simple. It means the a will affect the exponent a will affect the a will affect the exponent of the a. The exponent of the a is 1. So m times 1 will give us m. And then the m will affect the exponent of the b. So b exponent what? M. Now the same applies to this. If I have a over b, where this one is exponent of y, this one is exponent of m. All exponents m, then what is going to happen? The m will affect the exponent of the a, that's the x, it will come and multiply. So we are going to have mx, then the m will multiply the exponent of the y, b exponent what? My. So it is just very simple as that. Very simple as that. Now example. If I have 4 over 3 all exponent 2, now this one means that the exponent will affect the 4, it will affect the 3. So we're going to have 4 exponent 2 and then 3 exponent 2. Now 4 exponent 2 is 16, whilst the 3 exponent 2 is also what? 9. So this one is simple like that. It is very simple. Now let me look at another example. Oh, okay, this one I've not proved. Now let's prove this one. Now because this one is variable, I can't use the variable to prove, because when the exponent is m, we don't know the particular number, so it will be up to infinity. Now so for SHS level, let me just use the numbers to prove for you to get it very well. Now let me prove this one. This one and this one, it is true, it is correct. Let me prove this. Now if I have 4 over 3 exponent 2, it means that the 4 over 3, this 4 over 3 is multiplying itself how many times? 2 times. So I'm going to have 4 over 3 exponent 2. It means we have 4 over 3 multiplying another 4 over 3. Yes, multiplying itself 2 times. So when it is multiplying itself 2 times, it's same as 4 over 3 times 4 out of 3. How do you multiply this one? 4 will multiply 4, which will give us what? 16. Then 3 will multiply 3, which will give us what? 9. So 4 will multiply, the numerators will multiply, the denominators will multiply. So that is what we are talking about. It's the same thing. But you don't have to go through this process to solve. Using this one will be the best method. Using this one to be the best method. Yes. Now let me look at this particular question. Let's look at this particular question. Okay, now note this one. Note this. This one is division, right? Now if I have a minus b all exponent m, this one is never equal to a exponent m minus b exponent m. No. Don't say that because of division, so when they are subtraction, we have to use the exponent to subtract. No. The same thing if I have a minus b all exponent m all exponent 2, it is never and ever equal to a squared minus b squared. Even if you have a minus b exponent 3, it is never and ever equal to a exponent 3 minus b exponent 3. Don't forget. Yes. Now let me explain this one to you. Now you see, sometimes the base will be negative, sometimes the base will be positive. I am talking about the base, not the exponent. I'm talking about the base. So we can have something like, so note this one too. We can have something like negative a exponent m. Now this one is very tricky. The answer is not the same as a exponent m. This answer is very, very wrong. Why am I saying that? It will depend on the exponent. I don't know the exponent. The exponent can be negative, it can be positive, but I'm talking about positive exponent. Positive exponent. So let's see. Now, if m is a positive whole number, if m is a positive whole number, then when we have negative a, all exponent m, what are we going to get? Now we can write this one in two ways. Pay attention carefully, because some of you interchange this one and this one and this, they are different, not together. Yes, look at it carefully. Now this one can have two sides. The whole thing can give you positive, the whole thing can give you negative. So this one can be the same as negative m. The same thing can give you the same as positive m. Now, what is the condition here? Now, this one will only give you negative m if and only if m is an odd number. Odd number. Now, look at this very carefully. Now, anytime m here is an odd, you know odd numbers start from 1, 3, 5, 7, 9, 11, 18. In that order, these are the odd numbers. Yes. Whenever the exponent is an odd number, everything will be negative. Now, we can get positive if the exponent is, if m is an even number. Now, anytime m is an even number, what is an even number? Even number is 2, 4, 6, 8, 10. In that order. Anytime m is an even number, you're going to get something like this. Now, let me go down with examples. Let's see. So I'm going to consider m to be a negative, a positive. Don't forget that it's a positive whole number. I'm going to consider m to be now this one either negative or positive whole number. I don't want to talk about negative number, yes, because if I want to talk about negative number, I have to change negative to positive, and I'll talk about it in a different property so that you can reason through. Yes. Now, so let me give you an example. Now, example, if I have negative 2 exponent 1, now this one is the same as negative 2. If I have negative 2 exponent 3, I am talking about odd numbers. Now this one will give us what? It's an odd number, so it's supposed to give us negative. Yes. This one is my negative 2 exponent 3. It is so simple as that. Because the property I gave you is that whenever the exponent is an odd number, everything will be negative. So whenever we have minus a exponent m, then we are going to get our minus a exponent m, and just like this. Now, if you want to prove it, it is very simple. What are we saying? It will give us this, which will give us what? Negative 8. Now, let me explain it here. If I have minus 2 exponent 3, it means that minus 2 is multiplying itself 3 times. We're going to have minus 2 times minus 2 times minus 2. Now, don't forget that if I multiply 2 by 2 by 2, I'm going to get 8. You get it? Now, let's multiply the negative. Negative by negative will give us positive. Positive times negative will give us what? It will give us negative when you apply your integers. Now, this is how come we made a conclusion that if it is odd number. Now, let me talk about the last odd number. Let's say exponent 5. If I have negative 1 exponent 5, this one is supposed to give us negative 1 exponent 5, which is the same as negative 1. Because 1 exponent any number is the same as the number itself. So negative 1 exponent number the number itself. But now, why am I writing negative 1? I'm writing negative 1 because the exponent here is 5, which is an odd number. Okay, now let's prove this one. This one means negative 1 is multiplying itself 5 times. I hope you've gotten the clue. So negative 1 times negative 1, negative 1. It is not a magic. What I'm doing here, it is not magic. I'm just making conclusion on certain things so that when you see it, you don't think plenty. You just have to go straight away and get the answer. because some of you interchange this one with this. Now, so this one means that I hope with this you can even reason through that whenever the exponent is an even number, you are going to get something proper. You get it? Now, so -1 exponent 5 give us what -1 times -1 times -1 times -1 times -1. Now 1 times 1, 1 times 1 times 1 times 1 is still 1. Negative times negative is positive, times negative is negative, times negative is positive, times negative will give us negative when you apply your indices. So with this one I can conclude that anytime the exponent is an odd number, I'm going to get what? I'm going to get a negative number. Now when the exponent is an even number, now so even number, let me start with what? Even number, let me start with so -2 exponent 2. So this one will give us 2 exponent 2, which is what? 4. Don't forget that I said whenever it is an even number, they're going to get a exponent m. Yes, the negative will go. Now why? The reason is that this one means that we have -2 times -2, which will give us negative and negative will give us positive, 2 times 2 will give us 4. Now if I have -1 exponent 4, 4 is an even number. -1 times -1 times -1 times -1. So everything will give us 1. Negative times negative is positive, times negative is positive. Times one negative will give us this. Don't forget. So when the exponent is even number, this is what we are going to get. So I have made myself clear, right? Okay. Now this is mathematics, so as I'll be teaching some small tricks, then we move on. Now this one I'm teaching a full detail of what? The indices. Now let me talk about the rule 6. Rule number 6. Let me talk about rule number 6. Now rule number 6, I'm going to talk about the fact that when we have an index and then the exponent is 0. Now when we have an index or when we have a number and the exponent is 0, it's always 1. So if I have a exponent 0, it is always 1. Now let me take this one let me take this one from the rule number 2. Rule number 2 is the division rule. Yeah, division rule. Now it's all these rules supposed to be in your head. You see what I'm teaching you? I'm not looking at anything. Everything is in the head. Yes, because a property is a rule. As a mathematician, you're supposed to know, or as a student, you're supposed to know. Now, so let me prove this one nicely. Let's see. Now, so this one is if I have 2 exponent 0 is 1. The same as if I have 1 is the same as 2 exponent 0. If I have 3 exponent 0 is 1. If I have 24 exponent 0 is 1. So 1 means different and not together. You understand? So if I have 1 and I want to change 1 in the form of an index, it depends. Someone can write 5 exponent 0, someone can write 10 exponent 0, you can write plenty things, but we are going to deal with this one based on the question given. Yes, so open your eyes here. Now let me prove this very, very quick. Let me prove this one very, very quick. Now proof. Now from the division rule, from rule number 2, we talk about the fact that if I have a exponent m divided by b exponent n, it is the same as what? It is the same as what? We subtract the exponent. So it's the same as a exponent m minus n, right? That is from the rule number 2. Yes, that's the division rule. Now, let me talk about this. Now, since we have a exponent m and then b exponent n, now let me consider this particular condition. Now, if m is equal to n, now if m and n they are the same, because I want to get the exponent of 0, so again we have a exponent m over b exponent n, because the m is the same as n and the n should be the same as n. Get it? So I can change the n to m, m to what? To n. Now don't forget that anytime I write a rational function, don't forget that the denominator is not equal to 0. The denominator, this one, is not equal to 0. Don't forget. Now, So what am I going to do? This one is the same as A. Oh, you don't forget this one's supposed to be A. We are having it the same base. Don't forget the same base. Sorry, the same base. I'm going to talk about the fact that rule number 2, the same base. Now, so if m is equals to n, then what am I going to do? It means I have to subtract the exponent, right? Yes. Now, I am proving a exponent 0. So let's see. So we have a exponent 0. A exponent 0 will give us what? I'm using this particular property. So I can write this one as a exponent m divided by a exponent m. That is a exponent 0. Why am I writing this? Because this and this, they are the same. Why are they the same? A exponent m, they are dividing, so I have to subtract the exponent, so it will be minus m. What is m minus m? M minus m is 0. So when I say a exponent 0, the same as a exponent m divided by m, a exponent what? M. You have to know they are the same. You get it? Yes. So now let's look at something here. So a exponent 0, which is the same as a exponent m over a exponent m. What am I going to say here? A exponent m. You see, if we have 2 over 2, what am I going to do? The 2 and then 2 will go in itself 1. 2 will go in itself 1, 3 will go in itself 1, because the 2 and then 3, they are all the same. If I have 4 over 4, then it means it will be 1 over 1, which is 1, because 4 going into 1, going into 2, 1, going to 4, 1. If I have 8 over 8, just like the same thing. Now, so if I have, so first I have proved the fact that this and this, they are the same. You get it? A exponent 0 the same as this, right? Okay. Now, so a exponent 0 the same as a exponent m over a exponent m, a exponent m, talking about this particular thing where m is the same as n. Now, it means this one will go into itself 1, it will go into itself 1, so everything will give us 1. Now, this is the main reason why we are saying a exponent 0 is always 1. This is the main reason why we are saying a exponent 0 is always 1. Yes, it is proved here. Now, let me talk about another property or another rule. Now, rule number 7. Now, rule number 7. So the system I'm talking about when a number is 7 and the exponent of 0 is 5, y exponent 0 is 1. Then the 10, q exponent 0 is 1. Any number exponent 0 is 1. Don't forget. Now, number 7. I'm still talking about the properties, the rules of logarithm, indices. Now, one thing is that if you know the rules make the thing so simple for you. The rules are supposed to be at your fingertips. And this one is supposed to want to make sure you subscribe, like the video, and then share, so that YouTube will recommend the video to many people. Now, let's move on. Now, if I have question 7, now this one is question 7. Rule number 7. Now, rule number 7, let me talk about a situation where a certain number or variable has a fractional index. Fractional index. I'm talking about fractional exponent. So if I have an exponent, what is a fraction? What is a fraction? Now, this one is known as a exponent 1 over n. Yes. What is a fraction? Yes. Now, example, if I have a exponent 1 out of 2, now what's the meaning of exponent 1 out of 2? The 1 out of 2 is the same as the square root. The same as square root of a. Don't forget that if you have 1 out of 3, exponent is the same as the cubic root. Don't forget this one from the previous way, from DHS, yes. We talk about something like this. And then when you have a exponent 1 over 4, this one means that we have the fourth root of a. So when you have something like this, you can change it like this. Or if you have something like this, you can change it like this. If you have the square roots, you can change it to like this. Now, so it means that when we come to this particular property, it means the denominator becomes the root. The denominator becomes so this one gives us root of what? N A. So this one is called the nth root of A. The nth root of A. The nth root of A. So the denominator becomes the root. And the denominator of the fraction becomes the root. Just like A exponent 1/4. So the denominator becomes the root. It is very simple like that. So don't forget. The denominator becomes the root. Now you can use this one to solve plenty of questions. We can use this one to solve many questions. And we have two ways we can use this. Now let me go to property 8, rule number 8. Now rule number 8, I'm talking about a situation where here is not 1, it's also a number. So for example, if I have A exponent m/n, now this one can be expressed as this. Now this one is the same as the denominator becomes the root. So I'm going to have the denominator being the root. The denominator becomes the root, or yes, the denominator here becomes the root. Then we have A. Then this particular m becomes an exponent. Look at this very well. This one can also be written as what? It can also be written as this. Now let me break it down. If I have A exponent m/n, now from this property, this one is the same as A exponent 1/2 all exponent m. Now why? If I use the you know that from the previous rule we talk about the fact that if you have A exponent m, it means the m will multiply the exponent of the A, which will give us A exponent m, right? I hope you remember this particular property. Yes. So this one means that when the m multiplies the n, we are going to get what? M out of n. So it's the same thing. Yes. And I want to take this one from this particular property. Now what's the meaning of A exponent 1/n? Is the same as what? The cubic root, the nth root of n. So this one means the nth root of n. The nth root of A, all having an exponent of what? A. Now you see how I've broken it down? It is very simple. Very simple. So the numerator becomes the exponent, whilst the denominator becomes the root. Don't forget. Now example. Now this one is rule number 7. Now example. Follow me closely. Now example. If I have A 5/3, what does it mean? Now this one is the same as A. It's been 1/3 multiplying the 5. You understand? Yes. What's the meaning of this one? This one is my cubic root of A having an exponent of 5. It's very simple. I hope it's simple. Yes. So the numerator here becomes the root. The numerator becomes the exponent. This one you can also write the exponent as the A exponent 5 is the same thing. Now for that matter, you can get a question like 10⁻² exponent 2/5. Now I'm going to solve this question in two ways. How are you going to solve? Now this one, we know that which one will be the root? The root will be what? The 5. The exponent will be the 2. I hope you remember. Yes. The root will be the 5. The 5 here. The exponent will be the 2. So this one is the same as what? 32 exponent 1/5 multiplying 2. Now this one means the 5th power, or the 5th root. The 5th root of 32, all exponent 2. Now the fifth root of 32, when you punch in the calculator, you're going to get 2. Now all exponent what? 2. Now 2 exponent 2 means 2 times 2, which will give us 4. So this one will give us 4. Don't forget this. This one will give us 4. I hope it's so simple. Yes. We can talk about a whole lot of questions where that deal with this one. We can talk about a whole lot of questions. Yes. Now let me learn this one and then look at another one. Now we have 2, right? I'm going to solve this one a different way. The answer was 4. I'm going to solve this one the same way. Now another way I can solve this one is, and I want to change the 32 in the form of index, or only the 32 in the form of index or exponent. So, but I have to consider the base here. The denominator here is 5. So I have to change the 32 in such a way that the exponent will also be 5. Because I'm going to compare it with the 5 here. Whenever we have 2 exponent 5, there is no way we can expand. We can write a partial value, because this one is a fraction. Yes, we can't say that the 32 is multiplying itself 2 times or 5 times, because here is exponent, which is 2 out of 5. 2 out of 5 is not 1. 2 out of 5 is not 2. The exponent 2 out of 5 is not 3. So we can't say that 32 is multiplying itself 2 times, 3 times, 4 times, or 5 times. No. That is why you need to manipulate it small. Yes. So another way I can solve this one without using calculator, I can express 32 to have the same exponent as the denominator 5. But I know that 32, the only way we can express this one to be an exponent of, or an index form, is when we have 2 exponent 5. 2 exponent 5 is the same as 32. So I'm going to write this one, 2 exponent 5, all have the exponent of 2 out of 5. Now what is going to happen here? This one will multiply. It's same as 2 exponent 5 times 2 out of 5. 5 will cancel 5. So we're going to get 2 exponent 2, which will give us 4. So this is another way we can express. You change the base to an index form, where the exponent or the index or the power is the same as the denominator of the fractional index or the fractional exponent. Then it will cancel, then you get a whole number. When you get a whole number, you know that the whole number, the exponent being a whole number means the number is multiplying itself that particular number of times. Yes. Now let me talk about another property, then I will come back to this. Now let me talk about inverse property. When I talk about inverse property, when the exponent is a negative number. Now, so when you have a exponent negative n. Now the rule is so simple that when you have a exponent negative number, if you have a exponent a negative number, now the rule is 1 over a exponent n. Now it means that you have to make the exponent positive. Now the thing is that if I have 2x and negative 3, this one there is no way I can expand, just like fraction. I can't say that the 2 is multiplying itself 3 times. No, I am wrong. I am very, very wrong, yes, because this one is not 3 times, this one is negative 3. Yes. So you first have to change it to fractional form. How do we change to fraction? Now this one is having the coefficient of 1, so 1 over, you change this particular negative to positive, so to be 2 exponent 3, which will give us 1 over. Now 2 exponent 3 means the 2 multiplies itself 3 times, which will give us 8. Very simple. So you need to understand it. The same way, if you have something like this, you can change it to this. So if I have 1 over 2 exponent negative 2, I will change it to 2 exponent what? 2. Because the moment it comes up to become an index form, the sign will change. If I have 1 over 5 exponent 3, then this one gives us 5 exponent negative what? Negative 3. The vice versa also works very well. Don't forget. Here is negative, so when it comes out, it comes to 2 exponent 2, don't forget. So 2 exponent 2 is 4. Very simple. And this one can be proven in a different way. Yes. Don't forget this. Now, let's see how we can prove this one. Now let me prove this. Proof. Now if I have a exponent negative n, you see I can write this one as this. A exponent 0 minus n. I hope it's the same thing because 0 minus n is the same as n, negative n. With the same as this. Now, from the division rule, don't forget that this one is subtraction. So subtraction means division of base. Don't forget that we have a exponent m over a exponent n, which means a exponent m minus what? N. The moment they are subtracting, it means previously double division. So subtraction of exponent means what? Division of base. Yes. And then addition of exponent means what? Multiplication of what? Multiplication of base. So the vice versa is also applicable, don't forget. Now, so this one can be written as what? A exponent 0, because here is minus, it to be a exponent what? N. Because this minus means division. Yes. Now, what is a exponent 0? A exponent 0 is 1. Now, divided by this one is a exponent what? A exponent n. So it means that anytime we have a exponent negative n is the same as 1 over a exponent n. It is proved. Yes. So whenever you get an exponent negative and then you need to change it to positive before you can find the value, make sure you take this one into consideration. Yes. Now let me talk about another property. I'm talking about plenty properties. Now let's see. Now property 8. Property 8. After I'm going to solve some questions, then we end it. Now property 8. Property 8. Now if I have this property 8, how am I going to solve? How am I going to solve property 8? Now let me consider A over B where the exponent is negative. I'm going to do this one in two ways. I'll do fractional and then do this one. Now, now the exponent is negative. How are you going to do it? It is so simple. What you do is that you turn this one upside down. This one will come down, this one will go up. Then the exponent, the negative will change to positive. So it will be over A. Then this one will be positive. It will be over A. Then this one will be positive. You change the negative to positive by turning this one upside and you reciprocate. When the exponent is negative, you reciprocate this one. When the exponent is negative, they are dividing, you reciprocate this. Now let's prove this one. Proof. Now, so if I have A over B, exponent negative n, now this one means that A is affecting, the exponent is affecting A, the exponent is affecting the B. Right? From the property 3 or some of the properties, we said this one affect this one to affect this one. I hope you remember when the exponent is positive. Yes. Now let me go ahead. This one means A exponent negative n divided by B exponent negative n. I hope this line here means division, right? There is no space, so I have to do it like this. Now, what's the meaning of A exponent negative n? Don't forget that A exponent negative n means 1 over A exponent n. You know what's the meaning of B exponent negative n? It means 1 over what? B exponent n. Now, per our knowledge in fraction, we can change this one to multiplication. In the bottom half, you can change this one to multiplication. So 1 over what? A exponent n. This one will change from division to multiplication. Then we turn this one upside down. So we'll have B exponent n divided by 1. Now what is going to happen is that we multiply numerators to multiply denominators. So we're going to have b exponent n divided by a exponent n. Now, what is b exponent n over a exponent n? Now, this one is having exponent n, this one is having exponent n. It means all of them are having exponent of n. So I can write it like b over a all exponent n. So this and this, they are all the same, right? So therefore, I can conclude that if you have a over b exponent negative n, it will give us this. But the simple knowledge is that you turn this one upside down. You see the b is now up, the a is down. Then the exponent is now positive. So this one is very, very simple. Now when it happens that the exponent can be negative, can be positive, can be any way, then yes, it can be fraction. I hope you are following. Very good. Make sure you make your own notes because I am teaching. Now, example, if I have 3 over 4 all exponents minus 2, this one is the same as when you turn it upside down, so 4 out of 3. Then I'll make the exponent positive. That's the first approach. Now then we apply one property. This one means that the exponent is affecting the 4, the exponent is affecting the 3. Now what is 4 exponent 2 is 16. Then 3 exponent 2 is also 9. So this one is as simple as that. Very simple. Yes. Now let's look at another one. $64. Okay, now let me use what? Okay, now 4 over what? 9 exponent negative 3 out of 2. Now how are you going to solve this? The exponent is negative and it is also fraction. So what we're going to do is that we are going to make it positive by turning this one upside down. So we have 9 over 4, then the exponent will be 3 out of 2, positive. Now what it's going to do is that this one will affect this one will affect this. Now we have so many ways of solving this one. Now the first method is I'm going to write a exponent 3 out of 2 and then 4 exponent what? 3 out of 2. Now don't forget that we said that this one means that the 2 becomes the square root. The 2 becomes the denominator becomes the root. So this one is the same as what? The same as the root of 9 all exponent 3, because I hope you remember from the previous rule, the denominator becomes the root. Yes. So the root of 9 all exponent 3. Now here the denominator also becomes the root. You're going to get the root of 4 all exponent 3. Now root of 9 is 3. See, 9 is a perfect square number, so all exponent 3. Now root of 4 is 2, so 2 exponent 3. Now what is 2 exponent 3 exponent 3 is 27. 2 exponent 3 is 8. So this is the answer. Now another way we can solve this one is after changing. Let me start from here. After changing this one, I'm going to express this one in the form of an index where the exponent is the same as the base here. So I have to express this one to get an exponent of 2. And I know that this 9 means 3 exponent 2. Now all exponent 3 out of 2. This is another way we can solve. Now this one means 2 exponent 2. And having exponent of what? 3 out of 2. Now what is going to happen here? This one and this one will multiply. So the 2 will cancel the 2. We're going to get 3 exponent 3. The 2 will cancel the 2. We're going to get 2 exponent what? 3. So here will give us 27 divided by what? 8. It depends on how you want to solve it. Yes. It depends on how you want to solve it. Brothers and sisters, These ones are very simple properties, very simple property. Now if I want to use a variable for this one, don't forget that is it the same? Yes, it is still the same. It's still the same. Now I'm going to leave you for only these properties. Now at this point, let me solve questions. I'm going to solve some questions with you. Yes, we are not going to joke here. Now, question 1. If I have square roots of 36 x exponent minus 3, I have some question I'm going to give you. Y x exponent 3. Now all this one divided by 4 x exponent 3. Now 4 x exponent 3 y exponent -3. Now we have a question like this. How are you going to solve? Now at this point, all of them are having a square root. You get it? Now what I'm going to do is that I can deal with the numbers, then you deal with the variables. Yes. So 36 divided by 4. 36 divided by 4 will give us 36 divided by 4 will give us 9, because 4 going to 36 9 times. 9 times. Now let me come to the variable here. This one is having x, this one is having x, and they are dividing. Now when they are dividing, what do? We subtract the exponent, don't forget. So I'm going to take one of the base x. This one's having the exponent of -3. This one's having the exponent of 3. So we are going to subtract. So we're going to get minus what? 3. Now here is y, this one is y. So I'm going to take one of the y. Then this one's having the exponent of 3. They are dividing, so minus, don't forget. And then we have minus what? Another 3. So we have minus 3. Now what is going to happen here? You have 9x minus 3 will give us minus 6. And then we have y. Now this minus and minus will give us plus, so 3 plus 5 will give us 6. Now don't forget that this one is a square root. Don't forget that if you have m, if you have a, b, exponent m, it means the a is affecting m, the m is affecting what? The b, from our previous property. Yes. The same way, if you have the root means exponent half. The root means exponent half. So if you have AB exponent half, it means the root means exponent half. It means this one is affecting this one is affecting this. You get it? Yes. Or root of A, root of B. So it depends on how you want to write it. Yes. Now this one means that the root is affecting 9 times the root is affecting x exponent minus 6. The root is affecting y exponent 6. You get it? Yes. Now this one is the first square number, which will give us 3 times. Now we have x exponent minus 6 having an exponent of root. Now the root means 1 out of 2. So it means that this one will multiply this one, the 2 going to 6 3 times. So we're going to get x exponent minus 3. Now when it comes to the y2, we're going to get y exponent 6 or exponent 1 out of 2. This one multiplies, so we're going to get y exponent 2. Y exponent 3, so we're going to get y exponent 3. So this is the answer. Now we can leave the answer like this, or we can also break it down. You see this one, the exponent is negative, so we can bring it down to become a positive, but I want to leave the answer like this. Yes, we have so many ways we can solve it, but this is one of the ways. Yes. Now let's take another question. Now I'm going to consider this particular question. 2 exponent n plus 4 now minus 6 multiplying 2 exponent n plus 1. Now the whole of this one divided by 2 exponent 2 n plus 1. Now how are you going to solve this question? We are going to solve this question. How are you going to solve it? Yes, you need to apply your indices. You need to apply your indices. Now I'm going to solve this one after. I'll give you a last question for you to go and solve. Now you see, if you have a plus b all over 2, it means that the 2 is dividing a, the 2 is dividing the b, so we can write it the same way. Now, so this one means that we are going to have 2 exponent n plus 4 divided by this one, 2. Now let me multiply the exponent. We're going to get 2n plus 2. Now minus. Now this 6 is multiplying this, so don't forget that you can't multiply the 2 by 6. If you have 2 exponent n, there is no way you can multiply this one because this one is not dot 2, this one is multiplication. You can't multiply the 3 by the 2 here because they have different bases. Now you're going to get what? 6 multiplying 2 exponent n plus 1 divided by 2 exponent n plus 2. Don't forget that I've expanded this one. Now at this point, since this one is divided, we subtract the exponents. Now since this one too is divided, we subtract the exponents. So I'm going to get 2 exponent n plus 2 minus the denominator 2n plus 2. Then minus, when you take this one, we have 6, 2 exponent n plus 1. We are subtracting the exponent, so minus the denominator 2n plus 2. You see how the thing is? Now at this point, let's expand. We're going to get n plus 2. Use a negative to multiply. So minus 2n minus 2. We have 6 multiplying 2. Expand this one. We have n plus 1 minus 2 and minus 2. 2. Now you see 2 minus 2 will give us 0. N minus 2n will give us minus n. Minus 6 multiplying 2. N minus 2n will give us minus n. Plus 1 minus 2 will give us minus 1. We are still solving. Now let me continue from here. Now from here we can write it like this. Two exponents minus n is the same as 1 over 2 exponent n. Right? This one, the form of an index, is the same as 1 over 2 exponent n. Now then we have 6. 6. Now with this one, now look at this. This one is having negative, this one is having negative. We have 2 ways we can write this particular thing. We have 2 ways we can write this particular thing. I can write it like 2 exponent minus n divided by 2 exponent 1. Did you understand? Now this one is so simple. This one is 2 exponent 1. This minus means division. So divided by 2 exponent 1. It's very simple. Now this is 1 over 2 exponent n minus 6. Now I'm going to cancel. This one is 2. 2 going to the 6 how many times? Is 3 times. 2 exponent negative n. We are still solving. Now let me clean this one. 1 over 2 exponent n. Now, because of the exponent negative, I want to make it positive. So we're going to get 3 divided by 2 exponent n. Now, what is going to happen here? The bases are the same. So LCM will give us 2 exponent n. So here will be 1 minus 3. Now, what is 1 minus 3? 1 minus 3 will give us 2 minus 2. So this one will be minus 2 over what? 2 exponent n. Minus 2 will give us 2 exponent n. Now with this one we can still do something about it. Yeah, we can still do something about it. Now the whole thing is the same as, I can write this one as, the whole thing is the same as negative of what? 2 over what? 2 exponent n. It's the same as this. Don't forget. Now, what can we do about this? Now, because the bases are the same, this one is 2, this one is 2 exponent negative, 2 exponent n. So I'm going to subtract the exponent. This one has an exponent of 1. This one has an exponent of what? N. So to minus 2 exponent 1 minus n. Now, this is the answer. You can leave the answer like this or like this. Don't forget that there's negative here. Get it? Yes, it is so simple. Now, I'm going to give you one question to go and solve. Now, solve this one for me. Try this. Now you are going to try this and then put your answer at the comment section. Now write your answer at the comment section. Yes, I want to see your final answer at the comment section. So after solving, just put your answer at the comment section. Bye bye. I'm going to meet you in the next video. Then we solve other questions. Bye.